Okay, so today we are talking about solving systems of linear equations. And what a system of a linear equation is it's just two or more linear inequalities that have been paired together. For example, y equals 3x plus 1 and y equals minus 2x minus 3. This is a system of linear equations. There's two very important concepts that you're going to need to know for sample problems for later, or example problems that we're going to do together later. When graphs of two equations are parallel, which meaning if they're running this way or this way, I guess to say, together on the same graph, then there's no intersection points. Therefore, there is no solution. The only solution to one of these linear equations is where they intersect. And so these graphs are running parallel to each other. There is no intersection point. Therefore, there will be no solution for those types of systems. When the graphs of two equations form the same line, all the points are solutions. So if we have one solution that gives us a line that looks here, and then we end up with the exact same line, another equation gives us the exact same line. Every point on that line becomes a solution to those equations. And therefore, we then have the infinite number of possibilities for our solutions. Some example problems here we have. So they say solve each system by graphing and then check your answer. There's three very specific steps on how to solve these types of problems. The first thing you need to do is graph each line. And so what we have here is we have y equals minus x plus 1, and we have y equals 2x plus 4. And so we've graphed these knowing that our intersection point, y-intercept points, is plus 1 here, and then my slope would be negative 1 over 1. And so it's down 1 over 1, down 1 over 1, down 1 over 1. Graph that line. In this line, we have y-intercept point of plus 4, that's our b, up 4, and our slope is going to be over 2, up 2. Well, I added some extra points in here and backed our equation up and graphed this line. That's the green line. So we've graphed each line. Then we need to find the point. Step 2 is find the point where those two lines intersect. And that point is right here. That's the point of intersection. You'll see it written throughout the lesson as POI. It's the point of intersection. And so that point then is negative 1, back 1, up 2. Negative 1, 2. Step 3 is very easy. It's just check it. So you take this point and you plug those numbers in. You take this point, you plug them into both equations, which we've done here. Y equals minus 1 plus x. Take your y, stick it in here. Take your x, put it here, and solve the problem. If it comes out to 2 equals 2, then your statement is true. That is the solution for that equation. Same thing here, y equals 2x plus 4. Take your 2, plug it in for your y. Take your negative 1, plug it in for your x. Do the math, you end up with 2 equals minus 2 plus 4. Well, minus 2 plus 4 is equal to 2. So 2 equals 2 again, it's true. So is this a possible solution for this problem? Absolutely, this is a solution for this problem. The solution is minus 1, 2. That is the solution for this system of equations. What you're looking for is a point. Where do those lines intersect? Okay, so we're going to walk through a practice problem over here real quick. And we're going to graph this one. So, all right, my point of intersection is negative 3, or sorry, my y-intercept point is negative 3. So, because I know that's that b variable back here, 1, 2, 3, put that point in. And then I know my slope is the m point, y equals mx plus b, is 3 over 1. So that means I go up 3 over 1, up 3 over 1, and up 1, 2, 3 over 1. Okay, and oops, I didn't grab my straight edge, so we'll just quickly use this. And I know my points are not dead on because I'm not using a actual graph, but they're close. And so this is the x minus 3 line. And if we do the green line, ooh, with my green I'll need to rearrange them, kind of red solo couple them and move them around a little bit. So I would end up with for this one, getting y by itself, I'd have y equals minus x, because I've moved that x across. And when I move it across the equal sign, I change the sign. So minus x plus 1. That's fairly easy to graph. Up 1 is my y-intercept. My slope is down 1 over 1, down 1 over 1. Oh my gosh, look at that. Down 1 over 1, down 1 over 1, down 1 over 1. And there becomes that. And so there is that graph of that line. So my point of intersection is over 1, up 0. Now let's see if that's a possible solution for that. We check it, put it in both equations. Y equals 3x minus 3. Plug your numbers in. Zero equals 3 minus 3 equals 0. That's a true statement. That's a possible solution for this equation. Plug it into this one. X plus y equals 1. Plug it in. Plug it in. 1 equals 1. Therefore, that's a true statement. Both of those are true statements. So the solution to this problem, the solution on this side was this point. The solution on this side is 1, 0. Now, remember I told you that you would need to remember those very important concepts. So if you need to take a minute, if you don't remember those very important concepts were, take a minute and hit pause and go back and look at your notes or back the video up so that you can remember those points, because you'll need to know them for both of these graphs. The problem says solve each system by graphing. Steps again, graph the inequalities, find the point of interest, check it. Or sorry, point of intersect, not point of interest. And so what we've done here is y equals x minus 6 and x minus y equals 6. We've rearranged it and we end up with, look at this, y equals x minus 6 when you rearrange that equation. I don't even have to graph these because I know that y equals x minus 6 and this equation here are the exact same equation. What we translate this into. So these are both going to be on the exact same line. Therefore, remembering back that when two equations are parallel, when they are on the exact same thing, there's an infinite number of solutions. So solve each system. There are an infinite number of solutions. Over here, we have 2 equals y equals x plus 4 and y equals x. Looking at these, I'll quickly graph them. And we'll go up 1, 2, 3, 4. And my slope on this one is going to be 1 over 1. So if I go up 1 over 1, I can also back it up this way. And graph that. And I can also graph this. I don't have an intercept, so that means my intercept is 0. And my slope is still 1 over 1, so over 1, up 1, over 1, up 1, over 1, whoops, excuse me, up 1, over 1. My lines are both parallel. They will never intersect, so therefore there is no solution for this. Remember, this one had an infinite number of solutions. This one has absolutely no solution. So let's try taking it just one step farther. Maybe the problem says to you, find two numbers with a sum of 6 and a difference of 4. Well, the first step you need to do, and there's a little bit different steps, but it's still the same. We just added a step in the beginning. The first thing I need to do is they're not giving me the equations. I need to figure out what those equations are from the word problem up here. And so the problem says with a sum of 6. Well, I know I'm working with two variables. It says two numbers. So why can't those two variables be x and y? So I take my x. So it says the two numbers, sum means add. It's the answer to an addition problem. So add those two numbers together and you should get 6. And if I subtract those two numbers, one from the other, I should get 4. So what I've done here, because it's hard enough to graph a specific problem without a graph paper, we've gone ahead and graphed these two equations. We said x plus y is 6. You need to rearrange that, so we end up with y equals minus x plus 6. Graphed that line. Minus x plus 6 looks like this. This is that two numbers put into the sum equation. We have, when you have the difference is 4, we have x minus y equals 4. Kind of shift that around and we end up with y equals x minus 4, and that's this line. They intersect here at this point. Therefore, the point of interest we're looking at, I keep saying point of interest, excuse me, point of intersection we're looking at is right here. And so the coordinates for that point, find that point of intersection, coordinates for that point are 5, 1. And so now we know that point of intersection, we can come back and put it into our equations to see if they're true or not. And so if we take these 5 and 1 and we put them into this equation, 5 plus 1 equals 6. That's a true statement. 5 minus 1 equals 4. That's a true statement. So the solution to this problem, or the two numbers they're asking us for, that we would have a sum of 6 and a difference of 4, the two numbers are 5 and 1. If we do the same thing over here, I'm going to take a quick minute to erase this. So we can use it again because I only have one. Okay, so we have find two numbers with a difference of 2 and a sum of -8. Again, we need to write the equations. They give it to us. Two numbers, two variables. Why can't they be x and y? They're easy to plot. So we have x plus y equals -8. Sum of the numbers is a -8. X minus y equals 2. Difference of the numbers is 2. So if we go over here and we have those same equations, we have x plus y equals -8, and we have x minus y equals 2. We'll need to do some rearranging. So if we take this x over to this side, we end up with y equals minus x minus 8. If we take the x over to this side, we end up with minus y equals minus x plus 2. Divide each one by -1 to get rid of that -1 out in front. And you end up with y equals x minus 2. So the two lines we're going to graph on here are y equals minus x minus 8 and y equals x minus 2. So let's start here. My point of intersection, my point of intersection is -8. So I go 1, 2, 3, 4, 5, 6, 7, 8. -8. My slope is down 1, fall 1, run 1, fall 1, run 1, fall 1, run 1. I can also back that up and go in the other direction. Okay, and again, I don't have a straight edge. Grab one real quick. Graph those points in there, much better. Okay, and so again, this was the y equals -x minus 8 line. Okay, the other line, we have y equals x minus 2. 1, 2. And my slope is up 1 over 1. Rise 1 over 1. Rise 1 over 1. Up 1 over 1. Up 1 over 1. I can do it the same thing, only in reverse. Fall 1, back 1 up. Fall 1, back 1 up. Oh, look. I've intersected that point, or that other line. Put those two lines on there. The point of intersect is here. It's 1, 2, 3, minus 3, fall 1, 2, 3, 4, 5, down 5. And so my point of intersection is minus 3, minus 5. To find out if that's true, I need to put it into my equations. So if I say, let's take these, and so we came up with, minus 3, minus 5. And let's see if that's a possibility for these two numbers that we're looking for. So if I put them into this first equation, x plus y, x minus 3 plus minus 5 equals minus 8. That's a true statement. So they work for that equation. What about the difference? The difference is 2. Minus 3 minus 5. Turn those into a plus. Minus 3 plus 5 is 2. That's a true statement. So the numbers I'm looking for in this particular situation are a negative 3 and a negative 5. Hope that helped.